This video follows section number 3 of your Unit 4, Unit 5 flipbook. In class, we've already filled out section 1, which is everything you need to know about vertex form, and section number 2, all the things you need to know about intercept form. So in this video, we're going to begin talking about all the things we need to know about standard form. Now, a lot of these things you've already learned. We'll go through them and review them, but there is a major part on the bottom flap of section 3 that we have not covered yet, and that is the thing we'll be focusing on for this week. So, first thing I want to do is take a look at the top flap of section number 3. This will follow the exact same format that we've been using for the other two quadratic forms. On the top here, we're going to go ahead and write what the normal standard form quadratic looks like. Y equals ax squared plus bx plus c. And then, as we have done in the previous two sections, section 1 and section 2, we'll go ahead and write a sample equation that we'll go through the steps as we learn the different properties of standard form. We'll take an equation and go through those steps. So we're going to use negative 4 squared plus negative 4x squared plus 4x plus 8. So we'll go ahead and use that equation. Alright, so let's take a look at how to find the vertex. Now, we have gone through this already in section number 5, where we talked about how to find the vertex when you're graphing a standard form. We've also talked about this in section number 4, where the essential question was, how do I convert standard form to vertex form? So to find the x value of the vertex when you're looking at a standard form quadratic, we use the formula negative b over 2a. Now, what's important about this is, I'm going to put a little notation here, you flip the sign of b. Let's put this in the underline. You flip the sign of b. So don't forget to do that. So let's take a look at our example. Here is our quadratic equation, and we're going to go ahead and let's label this right above. Our a value, let's put this in a different color so you see this. Our a value in this case is negative 4. Our b value is equal to positive 4, and our c value is equal to 8. Again, I reminded you of this before. It's really important that you actually write this down. Take a couple seconds and do this. If you don't do this, there's a lot of times that students will pull the wrong values out of the equation. If you label a, b, and c, the next step is not that difficult. Let's take a look at our formula. It is negative b over 2a. Our b value is 4. That means we're going to take the negative of 4. So we're going to have a negative 4. And then on the denominator, we have 2 times a, which is negative 4. Let me fix that line there a second. So 2 times negative 4. All right, let's go ahead and finish this up. This is negative 4 over, well, 2 times negative 4 is negative 8. Go ahead and plug this in your calculator. Negative 4 divided by negative 8. It's going to give you 0.5. We also know we can reduce this. The negatives cancel because a negative divided by a negative is going to give you a positive number, just like negative times a negative gives you positive. We're going to end up with a positive value, and then we also have a common factor of 4 in each of these. It's going to end up being positive 1 over 2. If you put that in your calculator, I'll accept this answer as well, 0.5, so 0.5. So there is the x value of the vertex. Now let's go ahead and take a look at how to find the y value. We've learned this about functions class. If you know the x value, just plug it into the equation and calculate it out, and you'll get the y value for the vertex. So the y value, again, you've seen this before in other sections. You just plug the vertex x value into the equation, or into the function. In this case, it is an equation, so into the equation, and solve for y. And solve for y. Alright, and that's all you gotta do. Let's go ahead and plug that in. So, our equation is y equals, remember, whenever you plug in a variable, you always put it in parentheses so you don't mess up the sign. We've got 0.5 squared, it's positive, so don't have to worry about a sign, I'll fix that 0, plus 4 times 0.5 plus 8. You go ahead and put that in your calculator. Let's do that. So we've got negative 4, and then parenthesis, 0.5, close parenthesis. We're going to square that. Then we're going to add 4 times 0.5, close parenthesis, and then we're going to add 8. And press equals, and we have positive 9. So our y value is equal to 9. So y equals 9. That is the y value of our vertex. So our final answer here, so our vertex is going to be at 0.5, comma, it's kind of spaced out here, let me get that a little bit closer, 0.5, comma 9. And that is the end of this section on vertex. Let's go ahead and scroll down now to the bottom of the page. We're going to skip the x-intercepts zeros because the rest of this is going to be review. So on the bottom of this page, let's talk about the y-intercept. Remember, the y-intercept is, at the y-intercept, let's put a little note here. It's x is going to be equal to 0 at the y-intercept. And on a standard form quadratic, you can see, class, if the x value, did I say y value? The x value is equal to 0. If the x value is 0, take a look. Negative 4 times 0 squared, that's just 0. And 4 times 0, that's just 0. So notice the y-intercept will always be the c value. So down here, you're just going to write y equals c. Okay, but let's make this a little clearer. The y-intercept equals c. So let's fit this in. So it is 8. So in this case, again, the y-intercept, what is it? It's just 8. So you can actually, you know what, let's go ahead and write this in coordinate notation. It's going to be 0 for the x and 8 for the y. Now take a look at how this works, class. Looks just like plugging in things in a function. You plug in 0 for our x value, and out comes 8. And again, standard form is easy since the y-intercept will always be the value of c. If there's no c value, then we know the y-intercept is 0. It's going to cross the y-axis at 0. Alright. Let's go ahead and do the bottom two sections here. How does A affect the graph? Just like we've learned already in previous units. A positive A. So a positive A, the graph's going to face up. A negative A, the graph is going to open or face down. And we know that as, oops, get this to write correctly, as the absolute value of A increases, as the absolute value of A gets bigger, the graph stretches. I'm not sure if I'm going to be able to fit that in there. Let's kind of put it down a little bit. The graph stretches. And of course we know that as the absolute value of A approaches 0, the opposite happens. As A, absolute value of A gets closer and closer to 0, the graph gets compressed, compressed, compressed until when A is equal to 0, the graph actually turns into a straight line. So positive A, it opens up, negative A, it opens down, and as the absolute value of A gets bigger and bigger and bigger, 2, 3, 4, 5, 6, 10, 20, the graph will stretch and get thinner and thinner. Okay? Last thing, how does C affect the graph? Well, pretty simple. Since C is the y-intercept, since C is the y-intercept, when C increases, let me write that a little bit. When C increases, think about it. When C gets bigger, the y-intercept gets higher, and that means the graph is going to shift up. So when C increases, the graph shifts up. The whole graph actually shifts up. And this is actually causing a vertical shift. It makes sense also, class, the opposite happens. If C is getting smaller and smaller, and then negative and bigger negatives, so -2, -5, -7, -10, as it gets more and more negative, the graph will shift down. As C increases, the graph shifts up. If you remember, class, in vertex form, it's exactly what the K value does. As K gets bigger, the graph shifts up. As K gets smaller and smaller and then goes into negative numbers, the graph will shift down. So that's it for this video. In the next video, we will cover the new material. Everything here so far I know has been review for you, at least it should be review for you. In the next video, we're going to cover how to deal with the x-intercepts of a standard form quadratic.